In the Beginning by Dr. Walt Brown, page 238. Look at the evidence for Grand Lake draining. This will be side canyons into Grand and Hopi basins on page 238. Side canyons into Grand and Hopi basins. Grand and Hopi lakes emptied in weeks, so the water tables surrounding their basins quickly found themselves hundreds of feet. Let's start. Grand Lake. In the Beginning by Dr. Walt Brown, page 238. This will be evidence for Grand Lake draining. Side canyons into Grand and Hopi basins. Grand and Hopi lakes emptied in weeks, so the water tables surrounding their basins quickly found themselves hundreds of feet above the dropping lake levels. Perhaps several Great Lakes worth of high-pressure subsurface water began seeking underground escape routes into those draining basins. Escaping groundwater exploited faults formed during the uplift of the Colorado Plateau and other underground channels many miles long. Those channels became destinations for even more escaping groundwater. The more water that flowed through these underground channels and their tributaries, the larger they became. In this way, hundreds of canyons formed that today enter the basins of the former Grand and Hopi lakes. One of the most picturesque is Canyon de Chelly, a group of canyons up to 25 miles long that radiate east of Chinle, Arizona. Canyon de Chelly enters Grand Lakes Basin from the east near its southernmost location in Arizona. See figure 121 on page 224. Let's see. Figure, okay. Okay, Canyon de Chelly right there. Okay, that's where it is. Just off of Grand Lake. All right, and we'll go back to page 238. Okay. Streams and rivers produce canyons with V-shaped cross sections, but most of Canyon de Chelly has a U-shaped cross section. U-shaped cross sections are produced by glaciers or by underground water flowing out from and undercutting canyon walls. Because no other glacial features are found within 500 miles, subsurface flow, not glaciers, probably carved Canyon de Chelly. Also, Canyon de Chelly has abundant rock debris at the base of its upstream walls, but little debris at the downstream end, because only the downstream end was swept by all the force of all the water flowing out of the water walls along the canyon. Relatively little high-velocity water would have passed through the canyon's upstream portions. Subsurface flow is also inferred at a few points on the south rim of Canyon de Chelly, where the side canyons begin at ridgelines. Little surface water flows from a ridgeline, but much subsurface water can flow from beneath a ridge line. Let's take a peek at this. Canyon de Chelly, Spider Rock. Okay, there's Canyon de Chelly National Monument. Here is Spider Rock. Okay, Spider Rock in Canyon de Chelly. 5 canyons, see right, converge on this 800-foot spire from the north, northeast, east, southeast, and south. It is hard to imagine terrain that would allow 5 surface streams, which always flow downhill, to carve canyons that converge at the same point from such different locations. However, subsurface flow, which is always in the direction of decreasing pressure, can produce this effect. Obviously, Spider Rock was cemented before the water that carved these canyons swept through this location. Wow, 800 feet. Okay. Mesas, buttes, and spires. No land features symbolize the American Southwest more than mesas, buttes, and spires. A mesa, which means table in Spanish, is a flat-topped feature with vertical walls formed by erosion, which rises above the surrounding terrain. A mesa is wider than it is tall. A butte is similar, but it is taller than it is wide. A very slender butte is a spire. So let's take a look at these. Mesas, buttes, and spires. This is on the next page. Let's read about them. Okay. Monument Valley. Part of the basin that held Grand Lake on the Arizona-Utah border is Monument Valley, the world's most famous location for mesas, buttes, and spires, and a familiar site for Hollywood Western movies. These features and Grand Lake extended thousands of square miles beyond Monument Valley. Grand Lake existed for at least a few centuries after the flood. The long cliffs spanning the horizons mark a small part of Grand Lake's boundary. The horizon. Oh boy. The boundary of that lake. As Grand Lake spilled and began carving the Grand Canyon, 100 to 250 miles to the southwest of Monument Valley, groundwater no longer trapped under the lake surged upward through the lower portions of the lake floor and within weeks carried off the material that connected these stark and magnificent landforms. Since Grand Lake drained a few thousand years ago, weathering has produced the piles of debris at the base of each mesa, butte, and spire. Okay. Okay, we saw the mesas, buttes, and spires, figure 136. Okay. The towering walls that are formed are strikingly vertical. How and when did they form? There are only two dramatically different explanations, one requiring millions of years and the other only several weeks. Why are buttes and spires concentrated in Grand Lakes Basin? Their adjacent buttes contain corresponding horizontal layers at the same level, showing that they were once connected. What removed the huge volume of sediments between the buttes, and where did the sediments go? Butte parameters are not streamlined, but scalped and irregular, so streams did not carve them. Besides, rivers and streams do not meander enough or flow in circles, a necessary first step if rivers carved buttes. Nor did wind carve these features because large nearby sand dunes are missing. What happened? Beneath Grand Lake's basin today is a 1,400-foot thick layer of sandstone. When Grand Lake was present, the sand was uncemented and saturated with water. Because sand grains are hard and somewhat rounded, water-saturated sand layers contain up to 40% water by volume. As the lake emptied, the relatively large channels between these grains allowed the high-pressure water under Grand Lake to discharge rapidly upward through the lowest portions of the lake bottom, the easiest routes of escape. With those upward torrents of high-pressure water came a mix of swirling sand and dirt that was quickly swept out of Grand Lake and down through the Grand Canyon, which was forming 100 to 250 miles to the southwest. The highest portions of the lake bottom, including islands, offered the greatest resistance to the upward surging flow, so those high regions remained intact. Cliffs along some lake boundaries and mesas and buttes internal to the lake began to take shape. Imagine sitting on the bottom of a shallow swimming pool, your head barely sticking out of the water, and therefore is an island. You exert little pressure on the bottom of the pool because your body is buoyed up by the surrounding water pressure. You almost float. Suddenly, someone pulls the plug and the pool rapidly drains. Now your entire weight presses against the floor of the pool. Had you been a newly forming butte resting on the floor of the rapidly draining Grand Lake, you would quickly press down on 1,400 feet of water-saturated sediments. It would be as if a 250 million ton rock with only a quarter square mile base slowly settled down on a water-saturated 1,400 foot thick sponge. Water would surge upward and erode the sides of the rock, making the butte slender. Its parameters scalloped and its walls vertical. The banks of Grand Lake, now quite high, would also increase the pressure on the 1,400 feet of water directly below. If that water could escape upward, a bank segment would become a cliff. This is why so many mesas and buttes formed in Grand Lake as the floodwaters drained from the earth. So that's side canyons, mesas, buttes, and spires from Dr. Walt Brown's book in the beginning, and you can get that at hpt.rsr.org. You get a flip book.